captions. But I think the biggest difference with us is we didn't have trucks that looked like a dog scratching his ass on the carpet. I think that's the problem. All right, so let's go ahead and get started. 7.213/8. Let me get my 7.213/8. I'm sorry, 7.213/8. Well, come on, you can do it. Is it a test question? Well, pretty much all of them are. Find the z-score that the area under the curve to the left is 0.49. Now, I want to ask you a question, Miss Callahan. Can you unmute your mic for a second? She can't unmute her mic. Okay. Miss Callahan, do you have these printed out? Hello?
It's not unmuting either.
Yes.
But she was unmuted. I heard her for a second.
Yes, I do.
Good. Do they help you?
Kind of, yes.
Okay. We still have people that haven't even, I don't see how they're doing the homework. Oh, yeah, that's right. About 10 of you aren't doing the homework, so I guess it does. All right, so we're going to go ahead and take this, and I'm going to fix it right there. And let's see, we got a mean of 0, 1, 2, 3, -1, -2, -3. And it says we want the area to the left. The area to the left of 0.49. Area to the left of the z-score, 0.49. No, wait a minute. Find the z-score, sorry, where the area is equal to 0.49. And they need to put 2 zeros there because it is understood in probability and statistics that if you have 4 decimal points, that's an area. And if you have 2 decimal points, that's a z-score. But for some reason, this book doesn't do that. And I disagree with that because most of the books that I've used in the past, they would have put 0.4900 right here instead of 0.49. So with that being said, 0.49 would be somewhere right in here. And the area to the left. So our z-score is going to be somewhere between 0 and -0.5, somewhere in there by the empirical rule. So let's go ahead and do our inverse norm. So second inverse norm. Second inverse norm. I'm sorry, second bars inverse norm, 0.4900, and they want it to the left, and paste. I got -0.03. And that is your z-score. -0.03. So, Miss Callahan, it probably would have helped you if you had those 2 zeros there to begin with, because you probably thought it was a z-score just like I did. Okay?
Yeah, I put it in the calculator as shown on your paper.
Yeah, you thought it
told
was
me-
z-score. So that's going to be negative 0.03. And that is a good test question. So that's a good one. I don't want that. Why is that even on here? Let me get out of this. I don't know what that is, but I'm going to get it out of the way. All right, so that's that question. Next question. And if you notice, my paper is right there waiting on the next question. And that is 7.2, 1710. 7.2, 1710. It says find the z-scores to separate the middle 34% of the distribution, blah, 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 blah. Middle 34%. So I take my handy dandy, got to find my middle 34%. That means 17 that way and 17 that way. So take my handy dandy ruler, and that is my line there and my line there. So I've got a z-score here, -1, -2, -3, 0, 1, 2, 1, 2, 3. So I'm going to have a z-score somewhere between 0 and negative. I'm going to say around 0.5. And that's negative. And then somewhere around 0.5 because they're symmetrical. So whatever the z-score is over here, it's going to be the same over on the right side. So that's the middle. I'm going to highlight that. The middle, I'm going to highlight that yellow because that's the middle 34%. So if that is 17%, then that means this area right here, and I'll color it green. That means that this green area here is what? If the yellow area right here is 17%, then what is this green area?
33%.
It's 30 what? 33%. And that means this green area over here is 33%. So all we got to do is find one. And I'm going to use the inverse norm over here on the left because they're symmetrical. Once you find this z-score, you're going to find this z-score. So take our handy dandy calculator and do inverse norm. And we're going to change this to 0.33 and enter. And our z-score on the left is -0.44. Therefore, the one on the right is 0.44. So the answer is positive or negative 0.44. So negative 0.44, comma, 0.44. Two good test questions. Let me leave that up there for the one or two people that might watch the video before taking the test. Any questions on that one? I don't think everybody's got their, yeah, everybody's got the video turned on. All right. Foreheads and ceiling tiles. Let's go to the next, so we don't have any more questions sent to us. So no more questions sent to us. Now I'm not going to go over the test. I'm going to let you look at it. It's not the test, it's a test. So we'll go ahead and do that since there's no more homework questions. And over 10 people haven't even done the homework or slightly done the homework. But that's up to you. So let's go to the handy dandy test. And assignment manager. And unit 3. And you don't have to answer any of those stupid bonus questions. So those are all gone. So there's the first question. The relative frequency represents the length of phone calls in George's cell phone during the month of September. Determine whether or not the histogram indicates the normal. It's not a normal curve. It's skewed what? Skewed left, because the data's on the right. So you would hit no, this is skewed left. Well, I guess it would be no, the histogram does not have the shape of a normal curve. Next, NPX, this is cumulative. So I'm going to take my handy dandy. I'm going to do some of these for you, but I'm not going to do all of them because y'all probably already know them all anyway. So just wasting time. So this one says N is equal to 9, P is equal to 0.6, and X is less than or equal to 3. So number line 0, 1, 2, 3, 4, 5, 6, 7, 8, 9, 8, 9. And there's a 60% chance, and they want to know what is the probability of 3 or less households. So that'd be your binomial CDF. So binomial CDF 9.6 and 3. So take your handy dandy calculator and second bars binomial CDF for cumulative. And that's going to be 9.6 and 3. I got 0.0994. So there is a 9% chance, or you could argue 10% chance, that you will have 3 or less households, or whatever they're asking, 0.0994. 0.0994. See, they tell you they want an area to type it in 4 decimal places, but when they give you a question with area, they give you 2 decimal places. And I think that's kind of wrong. That's just not, I don't know what the word is. It's kind of crooked. Oh, I didn't check it. Let me check it. Let me go back and check it, make sure I got it right. Yep. Next. A new phone system was installed last year to help reduce the expense of personal calls that were made by employees. Before the new system was installed, the amount being spent on personal calls followed a normal distribution. Average. So I've got to use my handy dandy $800 with a mean of 50. So that's going to be 850. That's going to be 900 and 950. That's going to be 750, 700, and 650. Refer to such expenses, personal call expenses, using the distribution above. What is the probability that a randomly selected month had a PCA between 675 let's see, 675 would be right here, and 890. Let's see, 890 would be probably right in here. So that's going to be 675 minus 800 over 50. And it's going to be 890 minus 800 over 50. This down here is called negative infinity. This up here is called positive infinity, but we really don't need it because we're finding the middle. So 675 minus 800, I don't know, negative 125. Somebody check my math. Over 50. And I think that's going to be negative, what, 2.5? Somebody check my math. Somebody give me a thumbs up on 2.5. What is 125 divided by 50? Should be, considering that there's, yeah, that'd be right. And over here, we got 890. That's going to be 90 over 50, which is going to be 1 and 1.8. So if you've got an old calculator, you have to figure the z-scores and do a normal CDF. If you got a newer calculator, then you can type in whatever you need to type in. Second vars, normal CDF. And that's going to be negative 2.5 to 1.8. Now, by the empirical rule, 68. Let's see. This right here is going to be, well, half of 2 is 1, so that's 14. That's 15. 15 and 34 is 49. 49 and 34 is 83. 83 and 10 is 93. I'm going to say around 94%, 0.9400, somewhere around there. 0.9579. 0.9579. So let's type it in. .9579 should be right there, and we got that one right. Find the z-score, which the area under the normal curve to the left is 0.9600. So the area is 0.9600. Area to the left is 0.96. Well, that's 2.35. So right in here somewhere. Let's see, 2.35. That's 2.5. So 90 what? 96. So 1.35. 1.35 would be a tenth in here. So I'm going to say 1.9. I'm going to say 1.9. That's my answer by the empirical rule. But they want to know area is equal to 0.9600. There's my drawing. I got 1.9. I think it's going to be around 1.9. So inverse norm, second bars, inverse norm, 0.9600. And it's going to be left because it said the left side. Ooh, okay. 1.8 against 1.9. 1.75 is what they got. Calculator equals 1.75, and that is the answer. See, this stuff ain't hard. 1.75. A random number generator is set to generate integer random numbers between 1 and 10 exclusively. What is the probability that, well, what is the probability of the random number generator generating a 7 or less? Well, you got 10. A random number generator is set to generate an integer random numbers between 1 and 10, following a uniform distribution. What is the probability that a random number falls on 7 or less?
Priority 1 message coming in on secure
Well, that
channel.
would be probability, but I've got one problem. Well, each one is 0.1. I guess each one, you got 1/10 of a chance. I'm going to go with 10 NPX. I've never seen this question before, but I will go NPX on this one. Now, I may be totally wrong. I'm thinking N is equal to 10. P is equal to 0.1 because each number is a tenth. You know, the probability of getting each number is a tenth, 1 out of 10. And they want 7 or less. N is less than 7 or less. Now, that's what I get from the question. Now, I don't know if that's what they're wanting or not because I've never seen it before. So second bars, binomial.
Mr. Hubert,
Yes.
you don't need a calculator for this problem.
I don't.
It's just like it's basically saying you have 10 different outcomes. What's the probability that you get anywhere between 1 and 7?
Well, you got to take each. You got to add up each of the probabilities. Let me try it and see what happens. 10. Probability is 0.1. And 7 is our, and I get a probability of 1. So I don't think that's right. Let's see what the answer is. I've never seen that question.
I think it's supposed to be 0.7. It's just there's
Well, I'm gonna go with
different
it. I'm gonna go with 0.7 because I've never seen that question before, and evidently it's 7 divided by 10. But that question should be in Unit 1. That's a Unit 1 question. Yeah. That question doesn't have anything to do with what we're doing. I don't know why that question's even there. Well, thank you. Thank you for your communication. Next. All right, this is precise. This is n is equal to 60. N is equal to 60. P is equal to 0.99. And X is equal to 58. So this is precise because it's equal to. So handy dandy calculator. Second, enter. Oh, I'm sorry. Second bars. And binomial PDF. And that's going to be 60.99 and 58. 60.99 and 58. I got 0.0988. .0988. Next question. Give me the area, give me the probability that you are going to get a score, let's say a test score, above 39. So that's our handy dandy curve. We got a 50 and a 7, so that's going to be 57, 64, 71, 43. 43 minus 7 is 36 and 29. Somebody please check those and give me a, a thumbs up. They look right. And they want to know what is the probability that your test score is going to be greater than 39. What is the probability that your test score is going to be greater than 39? Well, 39 is going to be right here, as a matter of fact. More than a test score would be to the right, which means 9999. So 39 minus 50 divided by 7 is going to be 39 minus 50 is what? Negative 11. Y'all check me. And 11 will go in there once. And that'll leave what? 40. And 7 will go into 45 times. I get 1.55 repeating, but somebody check me. What is 11 divided by 7?
1.57.
1.57, thank you. So we go from 1.57 to 9999. Second vars, normal CDF, negative 1.57 to 9999. You got a newer calculator, you can punch in 39 and put in the mean and the standard deviation. In this case, 39 and 7, or I'm sorry, 50 and 7, and it'll give you the same answer. 0.9418. 0.9418. Again, they ask for an area, and they say round to 4 decimal places. But when they give you an area, they give you 2. 0.9418. Okay, chapter 6. Go ahead and write that down. It says determine the required value of the missing. Okay, this is simple. That's not hard. Somebody tell me you don't even have to do anything. You just have to think in your head. 30, that's 45, 70, 74, 26.
Yeah.
Somebody check my math. Yes or no? Okay, I got one person. Yep. Next. Steel rods are manufactured with a mean of 24 centimeters. Cause the variability of the are normally distributed. Okay, this is a curve. So 24 centimeters is in the middle. And we've got 0.07. So 24.07 is 24.07. And 24.14 and 24.21. Going backwards, oh, I hate subtraction. That would be 23, 2393, 2393, and then 23, what, 80, 86, and then 2379. Somebody check my math, please. And they want to know, it says, A, what proportion of rods, or what's the area, or what probability of rods has a length less than 23.9? So here's my my green, less than 23.9. Well, 23.9 is going to be right in here. There's 23, so 23.9 is going to be right there. So they want to know how many, what's the percentage that falls between 23.9? Well, 23.9 minus 24 over 0.07. I'm going to do that on the calculator. So clear. 23.9 minus 24 divided by 0.07. Negative 1.43. So we're going from negative 9999 to negative 1.43. Second, bars, normal CDF, negative 9999 to negative 1.43. And enter, enter, enter. 0.0764. 0.0764. 0.0764. So 7.64% is going to be below that length of 23.9. 0.0764. 0.0764. Glad they want it in 4 decimal places. Any rods that are shorter than 23.84 or longer than 24.16 are discarded. What portion of rods will be discarded? So 23.84, so less than 23.84, length less than 23.84, and greater than 24.16. So 23.84 is going to be right here. And 24.16, which is symmetrical. This is symmetrical. 24.16. And that's going to be this area right here. So you're going to add these two together or multiply them by 2 since they're symmetrical. So we'll just find this one and multiply it by 2. So second, enter. Negative 9999 to, we've got to change it to a z-score. I forgot about that. And I'm doing that because this old calculator, I'm going to treat everybody like they have an old calculator. If you got a new calculator, you would type in 24 and 0.07 and for the mean and standard deviation and 23.9 and get that, or negative 9999 to 23.9, and that would give you this answer. So somebody give me the z-score, 23.84 minus 24 over 0.07. And somebody give me 2 decimal places, please. It's going to be like, what, negative 1.98 or something? What does it come out to be? 23.84 minus 24 over 0.07. There it is, 23.84 minus 24 over 0.07. What do you get?
Negative 2.29.
Oh, I got it on the wrong side. Okay. Negative 2 point what? 29? It's right here. Okay. So 2.29, so I'm going to put that in the calculator. Negative 2.29. And enter. Multiply that by 2. 2%. So this your orange area is 0.0110. 0.0110, and this is 0.0110, And together, it's 0.0220. So 2% is going to fall in those parameters. Again, it asks for 4 decimal places. I can't answer it until. Use the results in part B, which is right here. If 5,000 rods are manufactured, how many should plant manager expect to discard? Somebody multiply, I'll do it. Because y'all won't answer me, so times 5,000. 110, now I'm not going to raise that up. I'm going to say 110. Now, this question right here, you got to think. It says, if an order comes in for 10,000 steel rods, how many rods should the plant manager expect to manufacture if the order states that all rods are between 23.9 and 24.1? So in other words, every rod that they put on the, every 10,000 of those rods have to be between 23.9 and 24.1. So we did 23.9. 23.9 come up to be 0.07 what? 64. So below 23.9, that came out to be 0.0. I done lost it. 0.0764. And then above, what is it? Above 24.1. Now we didn't do 24.1. We did 24.16. But 24.1 would be 0.0764. I think, but we're going to check it. What is it? 24.1. That's, I think, so let's check 24.1 right quick. I'm going to check it because I don't trust these numbers are too close to each other. So I'm just going to do a quick new calculator, and I'm going to make 24.1. Here's how you would do it with a new calculator. 24.1 to 9999. Mean is 24. And the standard deviation is 0.07. It should be 0.0764. Yeah, 0.0764. So 0.0764. So we're going to have to make enough rods. Okay, we're going to have to make enough rods.
Hey, Mr. Hubert,
Yes.
could you not just set the two boundaries that it gave you as the lower number being the lower boundary and the higher number being the higher boundary to find the in-between for the normal CDF on the calculator?
Well, you could, but the problem is you've got to overcompensate because you got to read the question. The question is saying, where's the freaking question? Hold on. I get so tired of having to flip between these things. The question is saying, if you own a metal shop and your order comes in for 10,000 rods, they have to be, all of them have to be correct. So that means you're going to have to make extra. You're going to have to do not 10,000. You may have to do 12,000 to get 10,000 that are correct. You see what I'm saying? That's the number you're trying to find. If it's not 12,000, is it 11,000 or is it 15,000? How many do you have to make sure that the order of 10,000 falls between these two?
Okay.
Okay. See, it says how many rods should the plant manager expect to manufacture if the order states that all rods must be, the 10,000 must be between 23.9 and 24.1? Now you've got a percentage now, 0.0764 times 2, 0.0764 times 2. And that's 15.28, 1528. So I'm going to show you something here. So you've got to get a number. Your goal is to get or calculate a number. And that number is going to be above 10,000 so that the good bars or whatever they're cutting is equal to 10,000. So if your good bars are equal to 10,000, the number that you made is going to be above what? 10,000, because some of them are bad. So, Walmart equation. And if you ever had me for any class, I don't know if I've shown you all the Walmart equation with percentages, but the Walmart equation, something I came up with as a teacher a long time ago. X plus or minus, oh shoot, X plus or minus percentage X is equal to the total. So we want 10,000. So X plus or minus percentage X is equal to 10,000. And we've got a percent of point what? What's our percent? 0.1528. X plus or minus 0.1528 X is equal to 10,000. I'm trying to get there. There we go. Now, what are we going to do with the discarded, let's just say bolts, okay? What are we going to do with the discarded bolts? Are we going to send them to them, or are we going to take them out? We're going to take them out, Hubert, because we don't want to send defective bolts to our client. Thank you. So we're going to get rid of the, it's going to be a minus. So 1 minus 0.1528 is equal to, and that's X, is equal to 10,000. And 1 minus 0.1528 is equal to 0.8472. And divide by 0.8472. So divide 10,000 divided by second answer. They're going to have to make 11,804 bolts. 11,804 bolts in order to get what? I want somebody to say the answer. We've got to make 11,804 bolts in order to get what?
10,000 good bolts.
There you go. So I got 11,804. Now, why am I not raising it to a decimal? Because there ain't no such thing as a half a bolt. Half a shot, but there's not a half a bolt. 11.11804. And that should be the answer. I want you to make a sentence on that last one because you need to understand what you just calculated. You just calculated how many bolts the company needs to make in order for a truckload of 10,000 good bolts to go out. You've got to make almost 12,000 bolts for a truckload of 10,000 bolts to be good to go out. So I'm going to put that up again so you can see it. Walmart equation, X plus or minus percentage X is equal to the total. You want 10,000 good bolts. There's your percentage of bad bolts. You're going to take out the bad bolts. So take out is subtraction. And do the algebra and you get 11,804. But y'all know how to do that, right? Nobody gonna say anything. I want to tell y'all a story. You know, midterms went out. I had to mail in, I had to send y'all's midterms in. Well, I've got high school students in all my classes. One of my students in my 120 class had a D, and evidently Bulldozer Dad and Helicopter Mom didn't like that, and got a phone call. I didn't get a phone call, but Tri-County Tech got a phone call, and the student told the parent that I was just unreasonable and I didn't give them time to take the test. So, of course, my department head said he gives his students 1 week to take the test online. He gives them 90 minutes to take the test, and he gives them 3 chances. The student only took it 1 time, made a D. Didn't take it 2 more times. Why? Either they wasn't motivated, or 2, they did it at the last minute and they couldn't take it twice. So they decided instead of facing the music, they would just lie about their teacher. Well, when the parents got word that they have a week to take their test and 90 minutes to take each test, and they could take it 3 times and I take the highest, you know what the parents said? We're sorry we wasted your time. Try not to lie to your parents, especially when you're dealing with me, because I cover all your what? I cover all your excuses. I'm not talking about y'all. I'm talking about another student in another class. Don't lie to your parents, especially when it comes to my class. All right, let's go back to the test. Let me see what time it is before y'all start convulsing. Okay, we good. We got 20 minutes. All right, so that's that one. Let's go to the next one. That looks like a freaking algebra question. All right, determine whether the graph represents a normal curve. Yes. Somebody tell me why. I'm not going to read all that. Somebody tell me why. It's dadgum symmetrical for one reason. Now, wait a minute. They may say it's not because of these 2 tails, but it looks like to me it's a normal curve. I don't know if they like these tails. I don't know if that, I don't know. Let's see. The graph can represent a normal density function. I say that's a possible answer. Increases as X becomes very large, very small. Negative values. I don't see any negative values. Oh, yeah. Can't have negative values. I'm sorry. So it would be negative values. Oops, I didn't check it. Check answer. Nope. Okay, 0. So it is a normal. I was right. Nope, I suck. The graph cannot present a normal because it increases as x becomes varied. Okay, down here. I didn't think the tails were right. Okay, that's not a very good question, but that's the answer. Write down the answer because I don't want you to get that one wrong. They're talking about the two tails. Those tails are supposed to go down and not increase. I didn't think those tails, they increase. They're supposed to keep going down. Potato, potato. Next. Okay. Suppose that a recent poll, 59% of adults believe that its overall state of moral values is poor. Complete parts A through C. For 250, randomly compute the mean, up 250, mean and standard deviation. Chapter 6. Mean and standard deviation, chapter 6, that means NP. So mean is equal to 250 times 0.59. So 250 times 0.59, 250 times 0.59, 147.5. And let's go ahead and do the standard deviation. Square root of 147.5 times 0.41. So times 0.41, and then raise that to the 0.5 power, and that is 7.78. So the standard deviation is 7.78. So there's your mean, and there is your standard deviation. So 140, I hate when they do this. I'm just going to say 148. 148 right here, and that's 8. So 148 and 8. So that's going to be 156. And that's going to be 164. And 8 would be 172. And 148 minus 8 is 140, 132, and 124. I made this 148. I made this 8 because I'm not doing those decimals while I'm trying to finish this test. I'm not going to explain. Okay, so we've got, let's see, it says round to the nearest whole number, so that'd be 148, and standard deviation of 8. Interpret the mean. Okay, it says for every 250 adults, the mean is the minimum number of would be expected to believe that the overall state of moral values is poor. Is the number of them that would be expected to believe that the overall state. The minimum, the number, I think the minimum, I like the minimum. For every 200, the mean is the range that would be expected to believe. I like the minimum, but I don't know. That's a Philadelphia lawyer question. Would it be unusual if 150 was believed? Would it be unusual for 150? Somebody tell me, would it be unusual for 150? Yes or no? Would it be unusual for 150? That means somebody needs to say yes or no.
No.
No, it would not. Why? Because where does 150 fall? Somebody tell me where 150 falls.
Greater than 0.05%? Or
Okay, I got a green area, I got a blue, yellow area, and I got a pink area. Where does 150 fall?
It falls in the green area. It's within 1 standard deviation.
And what is the green area called? Okay, I guess I didn't show y'all this curve. So I didn't show y'all the colors in the curve. I didn't show y'all this curve. I didn't show y'all the green normal.
No, you did. You did. You showed us.
Okay, so y'all are just doing what?
The mics aren't unmuting. I mean, it's hard.
Oh yeah, it's real difficult to look at 150 right there in the green.
No, we were trying to unmute our mics and they weren't unmuted.
Oh, okay. Okay, you're excused. All right. Would it be unusual? No. Now the only part that I'm weary of is the Philadelphia lawyer question. So if I get anything wrong on this, it's the Philadelphia lawyer question. So I'm gonna hit B. Well, there's, I think, the answer, but did I mess up somewhere? Yes, B is the answer. They say I got something else wrong, but I have no idea what else I got wrong. Did somebody get a mean of 148 and a standard deviation? Oh, round to the nearest. This is so stupid. Why would you round the mean to a whole number and then the standard deviation to a decimal? That's so stupid. 7.8. Okay, are you satisfied? Okay, somebody write down that answer. The number of them that would be expected to believe the overall state of moral values is poor. Heck, I can't even understand what that says. The mean is the number of them that would be expected to, okay, I guess if you can understand that, write that down because that'll be your answer. All right, let's try to finish up before y'all start convulsing. Okay, number of chocolate chips in 18-ounce, blah, blah, blah. I'm not doing this one, okay, because these numbers are too big. But I will I'm going to set it up for you. But I need somebody to give me the numbers because I'm not going to do it on the calculator. I'm not doing all these numbers, so somebody's going to have to add them up. All right, 1252 is in the middle. And I need somebody to add 129, 129, 129. I need somebody to subtract 129, 129, and 129, please. I need one person to give me the right side, and I need one person to give me the left side. Please do not try. If y'all all try to talk at one time, I believe that room in that building at Crescent will probably blow up if you try to do that. So don't try to talk at one time. So somebody give me the right side. Somebody, one person, please.
1381.
1381.
1510.
And one more.
1639.
All right, I need somebody to give me the minus side, please. Come on, you can do it.
$1,123.
Okay, next one.
994.
And the next one.
865.
Just listen to y'all. Y'all are just communicating. Thank you. And of course, they're going to ask you, you know, what is the probability between 1100, and you're going to have to calculate that z-score or put it in your new calculator, 1252 and 129, and then do it between 1100 and 1500, and then less than 1000, and then more than 1225, and then inverse norm. Let's see, what is the percentile? Okay, and then 1425, what is that percent? So there's 4 questions right there. I'm just not going to do it because it's too much. I'll help you set it up. Next question. We'll go back to it if we can. Okay, this is the one I wanted to get to because I knew there was one on here. They want you to find, okay, is this a probability distribution? So I'm going to check it right quick. And all the numbers are positive and between 0 and 1. So I'm going to pull it up and I'm going to just add them up right quick. If it will hurry. I got 9 minutes, please. Hurry. I'm going to make it a little bit bigger for y'all. Okay, I'm going to add those up. And that is what in the, I don't know what just happened. Hold on. I'm about ready to quit. Okay, so that equals 1. Are they going to ask for mean and a standard deviation? Let's look and see. Yep, they're going to ask for mean and a standard deviation, so we might as well go ahead and do that too. So the mean is going to be the summation of x times p of x. So that's equal to this times this. And I'm going to copy that down and add that up. All right, somebody write down that mean, 1.6269. And then over here, I'm going to do x squared times p of x. I'm going to just do it in one swoop. X squared times p of x. That's going to equal this number raised to the second power times this number. And I'm going to add that up. And the variance, that's the mean right here. Variance is going to be equal to this guy minus this guy squared. And then this guy, standard deviation, is going to be equal to the square root of the variance raised to 0.5 power. All right, so somebody write down those 3 numbers. I'm going to write them down too because I'm not going to try to remember them. So 1.6269 and 1.383, that's the variance, 1.38309,639, and the standard deviation is 1.176051185. And what does it look like? Let's see what it looks like right quick. Insert chart plot. That's what it looks like. Goes up then down and levels out. So it is all the probabilities are between 0 and 1 inclusive, and the sum of the probabilities is 1. And it looks like it levels out right here, D, and the distribution is skewed right. Multimodal, I don't know what that means. Skewed right. And the mean says round to what? Do not round. Okay. 1.6269. Which of the following of the mean is correct? Would expect the number per games to be the mean. If any number of the games would expect the mean number of hits per games to be, no, not to be. The observed number of hits per games will be equal to, no. The observed number of hits will be less than, expect, D. I'm in a hurry, so I probably looked over the right answer. Compute the standard deviation, round to 3 decimal places. Don't round this one, but round this one, so that way you'll mess up. 1.176. 1.176. What is the probability of 2 hits? 0.2840. And what is the probability more than 1 hit? Well, more than 1 hit would be these two added up, subtracted from 1, and that's going to be 1 minus parentheses 0.1675 plus 0.3361. Close parentheses, 0.4964. 0.4964. And there's only one question that I don't know if I got right or not, and that's that Philadelphia lawyer question. And that's probably it right here, so I'm not going to worry too much about that. Let me see the score changes. 84. 84. 84. Okay, I got that one right. So I must have a rounding issue somewhere. Round to 3, do not round, or that multimodal, let me see. That's it, has one mode. All right, so that's that one. Next question. I got 2 minutes. Okay, we did one like this, and this one says between 56 and 68. So that's C. Get your z-score for 56 and a z-score for 68, and run the normal CDF. Okay? Wait a minute. What's the mean? The mean is 65. Yeah, that's it. Next. Find the area under the standard normal curve between, okay, this you don't even have to draw, just go from negative 1.5 to 2.5. Negative 1.5, that'll be 7 and 34, 41 be 82%, close to 82. Okay, I don't know. I'm just going to go forward. There's your uniform distribution. So 9 minutes. The probability that friend is at least 9 minutes late. 9 minutes, at least 9 minutes. So that's going to be 9 from 31, which is 20, what? 21. So that's going to be 21 times 1/30. So 21.
Hey, Mr. Huber.
Yeah.
Our bell just rang, and some of us have
Okay.
sports that we have to get to.
Y'all go ahead. I'm going to keep on going and do these last couple. Y'all already taking the roll. Get out of here. Y'all have a good one.
All right.
You too.
7,
You said what?
0.7. And the last few, let's see what this next one is. Find the z-score for which 90% of distribution lies between negative z and positive z. So I'm going to take my handy dandy curve again. You going to stay with me, Miss Wiles? All right, so 90% of the distribution between negative, so 90% would be 45 this way and 45 this way. So that means on this side is 0.05, and it's symmetrical, so I just got to get the z-score for 0.05. So I'm going to do second bars, inverse norm, 0.0500, and left is fine. And that's negative 1.6. You could argue negative 1.65, but since the 4 is not there, I'm going to say 1.64. Negative 1.64 and positive 1.64. And that's your answer. So let's see. Next, 18. There are 2 college entrance exams and often taken by students, the SAT and the ACT. The composite score on the ACT, approximately normally distributed. Now let me get 2 curves here. Where's my 2 curves? Okay, this will have to do. I have one with 2 curves. Let's see if I can find it. Nope, can't find them. All right, we'll have to do it on this one. So the ACT is normally distributed 21.1 with a standard deviation of 5.1. So that's going to be 26.2, 31.3, and 36.4. I'm not even going to try to subtract it because I won't be able to. Let's see, 5.1 subtract, that's going to be 16. 16 minus 5, that's going to be 10 point, let's see, 16 minus 10.9 or something like that. And then 10.9 minus 5.1 is going to be 5.8. There's your ACT. And then the SAT, let me put these up here so you can see it. The SAT, 1026, oh, this is even better. 1026 at 210. So that's going to be 1236, 1446, and 1656. And I can't do 210. 210 backwards. That's going to be 816. Hell, I don't know. 816 be 606. And then 606 minus 210 would be 490. I don't know. Anyway, I don't know what those numbers are. And it says, suppose you scored a 28 on the ACT, a 28, and I'll put it in green. A 28 on the ACT would be right in here. And a, what, 1198 or 1200 on the SAT. Which one has the highest percentage? Okay, so we're going to find both of them. So I'm just going to do it with the new calculator, so I ain't got to convert a z-score. So I'm going to do second bars, normal CDF, and the lower is going to be 28. The upper is going to be 99.9, and I've got a 21.1 and a, what's the z-score on the first one? Did it say 5.1? Okay, I got 0.08. 0.08. That's not right. Oh, okay. Okay, I see. 90, I'm at the 92 percentile. I got to subtract that from 1. Subtract from 1. I'm at the 91st percentile. So let me go back to the picture. I'm at the 91st percentile. 0.91, what? 9120. 91.2 percentile. So let's see what the 1200 is. Second bars, normal CDF, and I'm going to go from 1200 to 9999, and I got a 1026, and 210 was my, and minus 1, ooh, 79th percentile. So 7963. So it doesn't take a rocket science to figure that out. 0.7963. So which one is higher?
The
ACT. You got a higher percentile with the ACT. So let's see what the question says. The score is because the percentile of the SAT is higher. I hate these. Why don't they just, the score of the SAT is better because the score is higher. No. The score on the ACT is better because the percentage, the SAT is better because the percentile for the ACT score is higher. That should be your answer. Next question. High temperature in a city for the month of August follow a uniform distribution over the interval from 66 to 96. For the high temperature, which is 90, of August days exceed. Okay, I'm a little bit confused. High temperatures.
That one confused me a lot too. I didn't get it right
last
time I took the test.
High temperature in a certain city, that's the high temperature. Or it must follow a uniform distribution, which is a uniform curve, over the interval 66 to 96. So I don't know if that's 66 to 96 is that 2 standard deviations, but I'm going to write it down. 66 to 96. Find the high temperature which 90% of the, okay, August days exceed 90%. So area is equal to 0.9000. Okay, it looks like to me, I'm going to try to back this thing in because it looks like to me, if your low is 66 and your high is 96, that's 30 degrees difference, right?
Mhm.
So if that's 30 degrees difference, then 15 has to be in the middle, right? So 15 from 96 is what? 85?
Yes.
And 85 to 96 is 11. No, 15. And this would be 5, 10, 15. So the standard deviation is 5. So this would be 90. No, that's not right. No, I've got to divide by 2. So that would be, I'm thinking out loud. Give me a second. So 15 divided by 2 is 7.5. So 7.5 plus 85 is 92.5. No. $66. Oh, wait a minute. 85 minus 66 and 96 minus 85. That should come out with the same number. Okay, 96 minus 85 is 11.
Yes.
Then this is wrong. 96 minus 15 is 81. 81 should be in the middle. That's why I couldn't get it to come out right. Now 7.5 added to 81 is 88.5. So that's right here. 88.5. 81 minus 7.5 is what? That's going to be 81 minus 7 is 84. 83.5. 83.5. And then 66 plus 7.5 is what? I'm not getting these numbers to come out right.
93.5.
Yeah, I'm not getting these numbers to come out right.
I got this question wrong both times that I took the test.
Well, first of all, I gotta get where I can write. Hold on a minute. Let me get one of these so I can write. These are too small. All right. 66 to 96 is, see, what they're not telling you if it's 2 standard deviations or 3 standard deviations. $66 to 96. Okay, now we said that the 96 plus 66 is 162. 81 is in the middle. 81 plus 96. Let's see, I can't do that because I got to find the middle here. That's why I'm not coming out. What?
It's 177.
I know, but I can't do what I'm trying to do here. 11 divided by, I know the distance here is 15. So that would make this 86 and this 91. There we go. Now we're cooking. All right, now we're going to add 5 here, and that'd be 71. And add 5 here, that'd be 76. Now we got it. Now, 90%. Now, this question is still very vague because it's not saying middle 90%. Find the high temperatures which 90% of August days exceed. I don't understand how to do this properly, because I just divided it up by find the high temperature which 90% high temperatures in a certain city for the month of August follow a uniform. It's a uniform distribution. It's not a curve. It's a uniform right there.
Oh, it's one of those
That's
boxes.
the difference from 66 to 96 degrees. So that means that the base is 30 and the height is 1/30. And they want to know 90% days exceed. Okay, find the high temperature which 90%. So 90% is right here. .9000 is right there. And 90% would be 90% of 30, which would leave 10% right here. So 10% of 30 is 3, so it should be 69 degrees.
Oh.
That's what it was. I missed that word right there. Uniform. So I'm going to let you look at that for a second and write it down.
Okay.
There it is. Amazing. In this class, one word can mess up the whole question. And it took me 3 times reading that question to see the word uniform.
I thought I needed to find a z-score that separated the bottom 10% and then the top 90%.
Well, you were very smart. I thought it was a normal curve too. And I read the question the 3rd time. So now let's see what the last question says. Assume that a random variable x is normally distributed with a mean of 60 and standard deviation. Compute, okay, this is a normal curve. And let me find a normal curve. There's one. Did you print these out, Miss Wiles?
I do have them printed out.
Did they help?
They help, yes. They help.
I guarantee you half the class don't have them. I don't know how they're doing it. All right, 60 and 16 would be 76. 76 plus 16 would be 92. 92 plus 16 would be 108. I have no idea.
Yeah,
60 minus 16 is 44. 44 minus 16 is 28. 28 minus 16 is 12. You better check those.
That sound right. Yeah, pretty sure.
16 and 80. 16 and 80. Well, since we're pushed for time, I'm going to put it in a new calculator, and we're going to type in the 60 and the, so second bars, normal CDF, and we're going from 16 to 80. And the mean is 60. And the standard deviation is, I don't forgot, 16. And let's see what we got. 0.8914. That's A. Let's see what we made. And I know I didn't do a couple of questions. But I still made 88. Let's see this question. Let's see what that question is. Okay, we didn't do that one. I told y'all, I picked it out, but I didn't do that. And what other question did we miss? I can't pull it up right now, but anyway. I didn't answer 2 or 3. And there's the last question. So now you've already taken the test. I think you made 80 something, didn't you?
Yeah, I retook it today and I made a 91.
But
the first time I took it, I made a 78.
Oh, well, why don't you do like the other people? Just take it one time and not take it a second and third time.
Yeah, I think that'd be a
Yeah, I'll
good
just
idea.
take my D. I'll just take my D and tell my mom and dad that Hubert sucks. Anyway, Miss Wiles, you have a good day. Do you know your uncle or your cousin is my neighbor?
Curtis?
Justin.
Oh, Justin.
He's your cousin, isn't
I did
he?
not know that. I think so. Is he the one that owns a car shop? No, that's not him.
He works for, I think he works for one of the, Ring doorbell.
Yeah.
Anyway,
Yeah, I'm pretty
he
sure.
bought a piece of land from me over here across Genesee Creek. And I talked to him a good bit, and that's why I didn't know. I know he's not out of Robert. I mean, he's not out of Jerry Wiles. He's out of Robert. He's out of Robert's people. So he's your
My
cousin.
mom said she graduated with you, but her
Who's your
last
mama?
name was Day at the time. Michelle
Who's
Day,
your mama?
I think her name was Michelle Day, but now it's Michelle Wiles.
Okay. Michelle Day?
Mm-hmm.
That was her maiden name?
That was her maiden name.
She went to school with me?
Apparently, she said she graduated with you.
Did she tell you any bad things?
No, she said you were a farm boy. That's all she said.
And I was a football player too, so.
Oh, really?
Michelle Day. I'll have to look that up.
And my boyfriend's mom had you as a teacher.
Okay, your boyfriend's mom had me what?
As a teacher?
Who was your boyfriend's
As a
mom?
professor? Heather Harbin. That's her name.
Yep, I remember Miss Harbin because we got some Harbins around here, and I always would ask her, who you kin to? So, well, that's good. She didn't say anything bad, did she?
No, she said you were funny.
Why is your class so difficult?
I don't know.
Your class
There's
is
a lot of
one of
difficult
the most
people.
difficult classes that I've ever taught.
Really?
Yeah. So,
Yeah. That's not
I don't
surprising.
know why. I don't know why. I know there's a bunch of good kids in there, but I have a feeling that there's a couple of people in there that are kind of
Yeah.
being I don't know, kind of like being a jerk. So
Yeah, I suppose so. I'm not in the same room as them. That's why it's okay.
I understand. Listen, you have a good day and good weekend.
You too.
Bye-bye.
Bye-bye.